Okay, I'm going to talk about the native budworm and DBM surveillance that Dusty Sevetson's team has been undertaking. So Dusty has a mic, so he can butt in at any time and add to what I'm saying. And then I'll give you an update of the red-legged earth mite resistance story and what's happened in 2022. All right, on to native budworm. Now, for those of you who have been around for a long time, you'll know that native budworm surveillance has been done by the department for many years. It has actually been going on for 32 years, being reported in PestVacs, and before that it was started by Kevin Walden in Geraldton during the 80s, I think, but it's been going on for a very long time. In the last few years, the trapping network has significantly expanded. This year we had 108 pheromone traps out. Now, all of you should be aware that a pheromone trap attracts only male moths. They come in and the trap actually has to be manually managed. So that means we are reliant on volunteers throughout the landscape to manage each of these traps, to manually count weekly how many native budworm are actually present in the trap, to give an indication that you've got native budworm in the landscape and you need to start baiting. It's quite time intensive. The project has been looking at ways to make this less intensive. So they've developed an in-house trap which is better at detecting native budworm numbers than other commercially available traps. It automatically uploads what the trap is finding throughout the season through the 4G network, and in real time you can get answers. The issue with it is that there are only 5 traps in the landscape, and the cost of actually mass producing this is not quite there. But hopefully in the future, that's what we're going to look at, is automated traps throughout the broadacre growing areas of Western Australia. Now, I thought I'd just give you a rundown, because I've just said for 30 years we've been doing native budworm monitoring, and I thought I'd give you the results from the last 6 years. The colours in the graph that you're seeing are the total numbers being found in the traps for the growing season. Now, in 2016, there were only 25 traps, but if you look at the numbers in the graph, you can actually have a look at Geraldton, and at Geraldton is where we first picked up native budworm in traps. And then the following traps throughout the landscape picked up native budworm. Now, if you have a look under the graphs, it gives you the number of traps that were actually being monitored throughout the landscape. In 2017, again, it was in Geraldton that the traps first started picking up native budworm flights. In 2018, this is when we expanded the trapping network. And again, Geraldton picked up native budworm first. So we're seeing a bit of a story here, but in 2018 there were actually reports that the trapping network had actually started too late, and that there were earlier captures or earlier occurrence of native budworm in the Geraldton area than what our trapping network was finding. In 2019, the traps were deployed a fortnight earlier, at least that's what we tried to do. Picked up native budworm again in Geraldton first, but the agronomists in that area indicated that it was still too late. So in 2020, mid-June, traps were put out, and again, Geraldton was the first place we found native budworm, and again, the indicator there was that the traps were still not getting out early enough to pick up that first flight of native budworm. Now, for those of you who were around last year, you'll remember that Dusty, when he spoke about when native budworm fly, it's got to do with the rainfall in the rangelands. So when the rainfall occurs in the rangelands from January to autumn, that's when we get the earlier flights. 2021, it's okay, we finally picked up the first flights in Geraldton. We didn't think we missed the boat there. And 2022, again, Geraldton, first moth flights. What's it mean for you? If you're in Geraldton and we don't have native budworm traps put out by June and there is rainfall in the rangelands, you will have earlier flights of native budworm occurring, and you need to start sweeping a little bit earlier. We have had native budworm causing damage to germinating crops in areas where they've arrived earlier than what we anticipated. If you're located elsewhere in the broadacre growing areas, good news for you is when the traps at Geraldton, and we report them in PestVacs, start picking up native budworm, you've got time. Now, native budworm, it's only the males that are being attracted, and when you look at the adjacent crop to where those traps are, it doesn't necessarily mean that that crop has lots of caterpillars in it. It means that there's moths in the landscape, because moths are very finicky, and it doesn't mean that they're going to land where the trap is and lay their eggs, and that's where you're going to have an issue. The other thing is native budworm count numbers do not indicate what level of egg lay is going to occur. They just give you an indicator that they're in the landscape. Start monitoring. Right, on to native budworm, diamondback moth surveillance, Now, diamondback moth surveillance, this is a new project that was only started in 2017. Yeah, I got it right. Okay, so there's 53 traps throughout the broadacre growing areas of Western Australia. Each diamondback moth trap is located in a canola paddock, and that canola paddock was monitored for caterpillars. We also trialled automated traps. Automated traps are really great because these manual traps require someone to go out there fortnightly and actually do a manual count of how many native budworm are actually caught on a sticky piece of paper. And again, they are only capturing males because it's a pheromone trap. So we've got some automated traps. They're from Slovenia, and the good news about these traps is that they work just as well as a manual trap, but you get real-time data, and no one has to go out there to check unless something goes wrong, and the system tells you if something's gone wrong. These are actually commercially produced from Slovenia, and again, would be lovely to see this throughout our broadacre growing areas as an indicator that we've got diamondback moth in our landscape. Now, just so that everyone's aware that the project, when they actually started monitoring for diamondback moths in the landscape, that what we actually picked up was what occurred during the growing season. During the January to March, surveillance occurred throughout the broadacre growing areas to determine where there was a green bridge. So the red dots on here on the graph to your, depends on where you are. No. Okay. The map to your left there, basically the red dots, no green bridge. Green dots is where a green bridge was found. Very low levels of diamondback moth were found associated with the green bridge because a trap was placed to any host plant that might be suitable for diamondback moth. So when the trapping network was deployed in May, we had very low levels of larvae present in the landscape. You can see that from the map on the right. Right. So the June trap results, so when we went back out, put the traps out in May, went back out in June and did a count of diamondback moths that were present in there, you can see that, this is not working for me, but you can see that the larger the circle, the more moths were captured on the June ones, and then those moths gave rise to caterpillars present in July. And you can see that on the right. So there's a correlation between captures of moths and the subsequent larvae that were found. And we see this as the season progresses, the traps captured moths and the crop then had subsequent larvae. And you can see this every single month. What this means is not that the crop has got lots of caterpillars. If your trap is capturing lots of moths, it does not correspond to the actual crop it's in getting lots of caterpillars. It means there's a lot of moths in the landscape. You need to start monitoring, because in many cases it wasn't the crop that we were monitoring where the highest numbers occurred. But it's a good indicator that there's DBM in the landscape and you need to start monitoring. In October, I got lots and lots of calls about diamondback moth being present in the landscape, lots of moths. Just want to remind you all, diamondback moth cannot survive in the absence of its host. So if there's no host plant, it can't survive. Those of you that are seeing a lot of diamondback moth right now on summer-grown millet or any summer-grown cereals, they won't do any damage. But if there is any summer-grown brassicas, yes, they will. So for those of you that are in horticultural growing areas, and we've had trapping results that show lots of diamondback moth in your area, expect them to move in. Now, from all of that, from all those 53 paddocks that were actually surveyed, only 4 had diamondback moth that were above threshold. Now, for those of you that can count, there's only 3 graphs up there because the 4th paddock, when the time for surveillance for diamondback moth occurred, it occurred on a very rainy day. No moths were found, and that actually confounds the results. So for those of you that are sweeping, do not sweep if it's raining because you're not going to capture enough diamondback moth. Now, at 2 of the properties, Trojan was applied. We don't know why Trojan was applied, but there is a idea going out that if you apply Trojan into crops, you're going to decrease the amount of egg lay occurring by diamondback moth. That does not happen. Okay, Kwinana East, South Muckamboodin, a Trojan spray was applied in early July. There were heavy rains from the 6th to the 18th of August at that site, and again on the 3rd to the 5th of September. That is the reason why the diamondback moth population crashed, not because of the application of Trojan. At Kwinana West and at Geraldton, Kwinana West, 2 applications of Trojan were applied. It did nothing for the diamondback moth population. It was the firm that actually caused a decrease there. And at Mount Horner, the only thing that worked there was the application of a firm. So take-home message there is really, if we are reporting diamondback moth trap catches in the landscape, start monitoring. But what I didn't mention is that it really is the conditions during the growing season that appear to impact on the development of populations of diamondback moth. Now, the project, as it goes on, will be looking at modelling this so that we can give you real-time information of when diamondback moth populations will increase. And for those of you that will be asking me, well, what about spraying synthetic pyrethroids for the suppression of egg lay in native budworm? Same thing, look, it doesn't work. Dusty can talk about that more later, but there again is the application of prophylactically of synthetic pyrethroids to stop egg lay really does not work. Now, onto my favourite little topic, red-legged earth mite resistance, and hopefully some ideas for management. The reason for bringing this up is this year we had a 40% increase, more so than any other year for our red-legged earth mite testing service, and we struggled to meet demand. It's one of the very few years I've not had to nail down agronomists and beg them to do collecting for me. We had quite a lot, and not only from agronomists but also from growers, and the demand went from May all the way through to, I even got calls in October. So anyway, one of the main reasons that occurred is that we had a lot of growers mainly in the Great Southern get caught out with peak hatching of red-legged earth mites. There is a red-legged earth mite hatch model available, which based on temperature and rainfall gives you when red-legged earth mites are predicted to start hatching. That does not mean that peak hatching has occurred. It means that that's when they're going to start hatching. So if you look at what happened in 2022, hatching started in pretty much the Great Southern from the 8th to the 25th of April. We got most of our inquiries in mid-May, when we had crops germinating where prophylactic spray applications had pretty much passed. So I thought I might just come up with what we actually surveyed and what we actually saw. So we had 57 populations that were bioassayed. For those of you that are still waiting results, there's another 40 samples that have been sent off for a PCR test. That's because synthetic pyrethroid resistance is a point mutation which can be detected by PCR. Organophosphate is metabolic resistance. We are looking for a mutation, but to date none has been found. Anyway, out of those 57 populations, 17 were resistant to synthetic pyrethroids only. 3 populations to organophosphates only, and the rest were cross-resistant. Now, you can see from there that you've got an N being only susceptible to, or the green dots being susceptible to synthetic pyrethroids, and you can see there's a bunch of mites. I really wish I could get my pointer to work. No. Okay. If you look to the Boyup Brook area, you'll see that there's a cross and a diamond shape. Keep that in mind for the next slide. So I've mentioned this already. Okay. One thing we've been looking at is how to get back to having red-legged earth mites that are not resistant to insecticides, because that would be the ideal, is to go back in time. There's a property out at Boyup Brook, which is the first property that was detected in 2009 with synthetic pyrethroid resistant red-legged earth mites and red-legged earth mites that were resistant to only omethawate at that time. We went back this year to see what had happened. We found no omethawate resistance, but the mites were all resistant to chlorpyrifos. What we also found at this particular property is that it was still resistant to synthetic pyrethroids. Now, what we had hoped, so if you see this map, you'll see that there's contour banks. Those contour banks can't be sprayed. So we had hoped that by keeping them unsprayed, we would see a decrease in the number of red-legged earth mites resistance, because resistance is recessive. So you need 2 individuals with a resistant gene and all their offspring are resistant. But if any of those individuals mate with a susceptible mite, their offspring are all susceptible. So we thought by not spraying the contour banks, you're going to see a decrease. And Peter Mangano, for those of you that do remember, undertook surveillance of these contour banks over a 3-year period where the property had basically gone into pasture, and it was in pasture again this year, and we still could not find that those resistant sites had gone back to susceptible. So bottom line is, you can reverse OP resistance by not spraying organophosphates, but with synthetic pyrethroid resistance, look, it persists. We know organophosphate resistance is hereditary, and we'll be going out again next year to all the properties where we had chlorpyrifos resistance a few years ago and see if we can still detect it, because those growers assured me they'd be stopping chlorpyrifos usage. But bottom line is, we do have a resistance management strategy for red-legged earth mites. However, if you can avoid spraying synthetic pyrethroids or broad-spectrum insecticides for the control of red-legged earth mites, or for any other pest unless you absolutely have to, you might preserve it for a bit longer. But once you lose the ability to control redlegs, it makes life a lot more difficult.